This video is going to introduce you to everyday physics and what you can expect from the course, the kind of time commitments you'll need so that you can do well in Phys 1110.
Hello and welcome to Everyday Physics. I'm Elizabeth Angsman and I'm the lecturer for this course. I'm the first year director in the School of Physics. So in this course we're going to get you to look at the physics behind lots of everyday phenomena. It's hoped that after doing this course you'll never look at the world the same way again. You'll be like, oh, but how does that work? I know how that works. And so this course has no university prerequisites. We do assume that you've done high school science up to the year 10 level and also mathematics. So this course does not cover calculus, you don't need any calculus, but you do need some algebra, so rearranging formulas, etc., some trigonometry, just with right angle triangles, so you need to know about SOHCAHTOA. And you will need a little bit of geometry as well. So if you're rusty on some of these topics, you may want to spend some time now revising them. There will be links underneath the lectures where these things come up to the Khan Academy if you do need a bit of revision of some of this maths. So in this course we're going to cover 12 topics. We'll be looking at how 12 different things work. So in this summer session version of the course, it's quite condensed. We're going to be doing 3 of these topics each fortnight, so that will be quite a lot of work, just a warning. So how it's going to work is each topic's going to look at the everyday phenomena and or an everyday device and the physics behind this. So for example, we'll start with street lights, and with street lights we'll be looking at electric current, we'll be looking at power, and we'll also be looking at the photoelectric effect, which is kind of exciting because it was some of the first evidence of quantum mechanics. And street lights actually use the photoelectric effect to determine when they should turn on. So with each of these topics, you're going to be provided with approximately 5 to 7 videos, which are equivalent to lectures. So these videos will cover the theory behind it, they'll look at relevant demonstrations, and then there'll be worked examples as well, showing you how to use these formulas. After that, you're going to have approximately 10 tutorial problems. So I highly recommend that you try working through these tutorial problems on your own. There's lots of educational research that shows that the best way to learn physics, actually the best way to learn almost anything, is to practice solving problems yourself. So have a look at the tutorial problems. They're all as a PDF. Print them off or read them on your screen. Have a go at them. And then for each of these tutorial sets there is a video which shows you step by step how to solve all the problems in the tutorial sheets. But try them yourself before watching that video. Now in this course, self-motivation is key. No one is going to check that you have done those tutorial problems. However, if you want to get the most out of this course, if you want to really end up understanding the physics, then you should be trying these tutorial problems yourself. Now, because physics is an experimental science, we have 6 investigations along the way. So these investigations, we've tried to make them possible with common household equipment. So there's a list in the course outline of all the equipment that you're going to need. You may want to start gathering this equipment together now. If you're in Sydney and you're having difficulty sourcing some of the equipment, like say you don't have a set of electronic scales for use in the kitchen, then you can borrow the equipment on 24-hour loans from the first year physics laboratory. So if you just go to the lab staff there, tell them that you're doing everyday physics, they'll get you to sign something and they'll lend you the equipment that you need for the investigation. But we do have limited sets of this, so it's for 24-hour loans and you can then return it so that other students can borrow it if they need to. So with this course, you'll be encouraged to check stuff out along the way. Because physics is an experimental science, you should not be trusting me that everything I tell you is actually correct. You actually need to go and test it for yourself. So along the way in lectures, where appropriate, we do suggest little tiny experiments that you can do at home just to verify that what I'm telling you actually does happen. So the first of these investigations that you're going to have to do is going to involve measuring the specific heat of water with a kettle. So for this one, you're going to need a kettle, stopwatch, a measuring jug, some water, and a thermometer is optional. So as we said, there's going to be 6 of these investigations along the way. There'll be one every approximately 2 topics. So each of these is worth 5%, giving you a total of 30% of your marks for the course. You're going to submit them as a report through Turnitin. Your tutor will then mark them and give you feedback. It's highly recommended that you look at the feedback that your tutor gives you before submitting the next investigation, so that if you made a mistake or did something not quite as well as you could have in the first investigation, you've learnt from that and you don't make the same mistake in the second investigation. So all this feedback and comments can be accessed through Turnitin. If you have any difficulty accessing that or any other parts of this course, then just email me or post up on the forum. Best to post up on the forum because other students are probably experiencing similar difficulties, so that you know where all this stuff can be found. Now, every fortnight in this course you're going to have an online test. So these online tests are each worth 10%, so there's 4 of them because they're fortnightly and it runs for 8 weeks, giving 40% of your final mark. Now, you'll have approximately a week to do these tests. You can look in the course outline to see exactly when they will be released and when they're due. Be warned, these online tests, because it's all open book, they are fairly hard. This is because we do need to distinguish between high distinction, distinction, credit and pass students. There is no final exam for this course, and so we try to use these online tests to distinguish between different levels of performance. It's not possible to get an extension on any of these online tests, because as soon as that test shuts down in Moodle, you're able to access the answers, see what the correct answer was, and we also release solutions showing you how to solve all of the problems. Now, the final component of your assessment is really the most interesting part. It's a final report. Now, in this final report, what you need to do is choose one phenomenon that interests you. So if you're interested in sport, you may want to look at a particular sport. If you love sailing, then maybe sailing. Or if you love music, then maybe look at how a musical instrument works. So you'll want to be looking at one of these phenomenons or devices and then working out the physics behind it. You'll then need to construct an investigation, like the investigations you've been doing through the course, to investigate the physics. So there's guidelines on suitable topics to choose on the Moodle page, and I also encourage you to post up on your group discussion forum your topic so that you can get some feedback from the tutor. So what you're going to need to do with this is, hopefully a few weeks into the course, you'll come up with a topic and start working on this topic on your own. You'll then need to submit a draft report for peer review. So you'll need to submit this on Moodle through the peer review tool, and it's really, really important with this one to submit it by the deadline. Because of how the peer review works, it's not possible to get extensions. So you submit your draft report for peer review. You'll then be looking at 5 other students' draft reports and giving them some feedback, and they'll be looking at yours and giving you some feedback. So 10% of your mark is actually going to come from the quality of the feedback that you give other students. So you're trying to help other students improve their report, and they're trying to help you improve yours. So you have approximately a week to do that. All the dates are in the course outline. And then you'll get the feedback and you'll have a little bit of time to update your final report from your draft report before you submit it to your tutor for marking. So your final report is worth 20% of your final mark, and you'll need to submit that through Turnitin on Moodle. Okay, so just a warning with this course. This course is an online course. This means it's online. It does not mean that it's an easier course or that there's less work in this course than in a normal 6-unit of credit course. This course is Phys 1110, and that physics code means something. So this is an introductory physics course. It teaches physics at around about the same level as our face-to-face course, Fundamentals of Physics, which is Phys 1111. So you are allowed to elect to do this course as a Gen Ed, but it appears on your transcript with a physics code, and the level of work involved is equivalent to other first-year physics courses. So just to give you an idea about how much time you should plan on spending in this course, it's pretty much the same level of physics as the Fundamentals of Physics course. In that course, during sessions, so over 12 weeks, the students have 3 hours of lectures each week, a 2-hour lab session and 1 hour of tutorials. So that's 6 hours face-to-face, and we expect them to put in a similar amount of time out of class. So that's 12 hours per week during session. Now in summer, we've condensed everything. Instead of 12 weeks, it's now 8 weeks. And so that would work out as, rather than the 12 hours per week, that would be 18 hours per week. So if you put 18 hours per week into this course, you'll do really well and you will get a lot out of it. So 18 hours per week would mean putting aside about 2 days per week to work on this course material. So clearly, because it's online, you're going to need to be self-motivated to do this, but I recommend now that you start planning on spending that amount of time on it. Now, under each lecture, there are readings provided. These are optional. They're there to supplement it. So if there's something that you didn't understand in the lecture, then you can post about it on the forum and get some help, or you can have a look at these readings. The readings, some of the readings also contain extra practice questions. So if you're wanting more practice questions than the 10 tutorial problems each week, you can often find some extra practice questions in these readings. So there's no prescribed textbook for this course, but there is readings associated with each of the topics, and you can access that free of charge from the library. Now, another few things to note: because this is running in summer, it's quite likely that a few of you are doing the course from overseas. Please note that all the submission times in this course are Sydney time, so you need to take that into account if you're overseas. Make sure that you know what the time is in Sydney so that you don't miss any of these deadlines. The easiest way to lose marks in this course is not to submit your work on time. The penalties are quite steep for not submitting work on time. For the investigations and the final report, it's 25% per day. With the draft report, you cannot submit that late, and the quizzes cannot be submitted late. The reason for this is that the tutors need to mark it and give you feedback before your next assessment is due. So it takes the tutors a little while to mark it, and we need to ensure that all these are submitted so that the tutors can mark it, give you feedback so that you can react to that feedback before the next lot of assessment is due. So I recommend that you print out when everything's due. It's all in a table on the course outline. Stick it on your wall and just keep on referring to it so that you don't miss any of the deadlines through the course. You can even submit everything early if you want to. It's just you don't submit it late. The other thing that you need to avoid is plagiarism. There's lots of links on the Moodle page to describe what plagiarism is. Submitting other students' work for your final report is plagiarism. Submitting work which somebody else did in another course is plagiarism. Submitting work for one of the investigations and then submitting it again for the final report is plagiarism. So make sure that you know what plagiarism is, and please don't do it, because it takes me a lot of time, it takes you a lot of time, you get a big red cross on your academic transcript about it. So please just don't do it. If you don't have time to do an assessment, then don't submit anything. That's better than submitting somebody else's work and pretending that it's your own. So I do hope that you enjoy this course, and I really hope that it makes you see the world in a different way.